Hello everybody, my name is Navjot Mahal and today I'm going to discuss on our final project of CIM and my teammates are Mahmood, Nawaz Baig, Shawn Hoyt and Juliano Ramirez. First I will discuss about what is a swivel bearing. Swivel bearing is designed to allow free rotation of the tool string and minimize line torque during cycling or cable development, meaning it is designed to rotate smoothly when subjected to forces, thus eliminating tension. The swivel bearing which we constructed consists of 12 parts. Swivel bearings are essential to specific application where possibility of misalignment can or does occur. Swivel bearing works on the following principle: the bearing block can revolve around the x-axis while the spindle revolves around z-axis, giving it a 4 degree of freedom. Our group has chosen this project because we are able to do DFM and DFA on the swivel bearing. Swivel bearing consists of like following parts: the base, which is made of cast iron, and the spindle is made of stainless steel. The knurled nut is made of stainless steel. The fork is made of cast iron. The bearing block is made of cast iron. And set screws are made of stainless steel. Lock nut is made of stainless steel. Bush is made of brass. Disc A is made of brass. Set, set screw A is made of stainless steel. Disc B is made of brass. And set screw B is made of stainless steel. So DFM, we use DFM in this in the swivel bearing because it focuses on developing a modified version to help shorten the cycle time, parts production costs, design flaws of the original product, all while ensuring that they are still manufacturing a good part. The guidelines of DFM are: design must fit and function within parts parameter, reduce number of processing steps and costs, prototype should be tested and pass. In, in our swivel bearing, what changes we made in DFM was like we changed the barrel. We removed all the casting process and used the available machines to manufacture the base in-house. The base was modified as a part of DFM strategy. In the following image, we can see that first the barrel was tapered, and then we made the barrel straight. The new design made the bore, like the base, more sturdy as well as easy to manufacture in milling machine rather than unprecise, rigorous, and labor dependent of the original design. Next, we changed the shape of the fork. The modification included removing of the rib and inclined surfaces, which are generally difficult to machine. Straight surfaces provide strength and ease manufacturing operations. You can see in the image, like the old design was tapered and the new design is straight. So the benefits of this DFM is the process of making tapered shape by casting is changed to machining for making cylindrical shape, which results in saving of material. Moreover, cost of making the sphere bearing is reduced by changing the material from cast iron to stainless steel. Change of the shape of the fork will help in simplifying the process of 3-axis machining. So the next steps my other teammate is going to discuss with you.
I'll be talking about DFA and the CNC simulation. DFA is designed for assembly. It is a process in which the assembly process is simplified by either reducing the total number of parts needed or reducing the assembly steps and combining multiple parts or standardization of different parts and making shipping and handling easier. For this project, we modified the null nut, the set screw A and the disc A, as well as we modified the base and the set screw B. For this project, the sets two parts were eliminated. That's a set screw A and the disc A, and we modified the set screw B to get accommodated in both the base and the null nut. The set screw, uh, the hole for the set screw A in null nut was M6. We modified it for M8, and the set screw A was modified from 10 mm from 11 mm to 10 mm, so it can be accommodated in both the base and the null nut. So in by this way we standardized a single part, reducing inventory and reducing the steps to assemble, as well as it makes easier for technicians to have a standard part rather than two different parts while assembling. So like I said, these are the changes. We changed the set screw A from M6 to M8 and the length from 11 mm to 10 mm. The total number of parts for the whole assembly after the DFM DFA process was brought down to 10 rather than 12 from the original assembly. For the CNC part, we use milling machine to manufacture the base. And the slide next will show you the simulation from the Fusion 360 cam. We use a bullnose milling tool for adaptive clearing. The tool is 8 mm in diameter and the corner radius is 0.5 mm. We choose the bullnose for the fillets that are part of the base. With 0.5 mm radius, we get a better radius. The next step is 2D contour. We use the same tool for the contouring, and we have given the command of multiple depths. Flattened mill is being used for the horizontal. This is 3D contour. This is used for refining the finish on the product. The next step is drilling and a tap, and the next after it was tapping. The hole was M20 by 2.5 thread pitch. The next was pocket. We created the two slots at the base, and right now this is a scallop. For this we use a 2 mm tool. For the hole at the bottom and the hole at the front face, we use consequent setups which are not shown in this simulation video. Moving on to the next slide. We made everything in Fusion 360 using the CAD and CAM. Fusion 360 can also do CAE. Thank you. This was a presentation on swivel bearing. Myself is Mahmood Nawaz Baig, and my teammates are Navjot Singh Mahal, Shawn Hoyt, and Juliano Ramirez. Please feel free to ask any questions to us. This video will be posted on Blackboard. Thank you.